Alright, let's go and take a look at lesson 2.1. 2.1 is all about adding and subtracting polynomials. The first thing we need to talk about is what is a monomial. Okay, a monomial is something that has one term. Okay, for example, 10. Okay, another example would be 3x. Okay, now we need to talk about the degrees of these monomials. Okay, so if we had a 10 as our monomial, to count the degrees, we need to count the exponent of any variables attached to our term. Okay, so we don't see any exponents attached to a term. Okay, in any case, it would be x is 0. So our degree in this case is 0. Okay, because anything to the 0 power is 1, so this makes it 10 times 1, which is 10. Right. How about in this 3x? Okay, to count the degrees, we have to add the exponents of any variable in our term. Okay, so in our term, we have one variable with an exponent of 1. So the degree is just 1. Right? Let's go and take a look at the next question. How about in 1/5 xy to the third? Okay, so to count the degrees, we need to add the exponents of any variables that we have in our term. So the x has a 1 and the y has a 3 as their exponents. So we have to do 1 plus 3, which is 4. So the degree in this, by adding the exponents attached to our variables, is 4. Okay, let's take a look at the next question. All right, how about in something that looks like 2.6 x to the 3 y squared z to the 7. Okay, so like I said before, we have to count the exponents, add the exponents of anything attached to a variable, any exponent attached to a variable. Okay, so 3 plus 2 plus 7. 5 plus 7 is 12. Okay, so by adding the degrees that are attached to variables, adding the exponents that are attached to variables, we get 12. Okay, now let's take a look at the next concept, which will show us a polynomial, and we need to write that polynomial in standard form. Okay, so if we had a polynomial that was written like this, 15x minus 7x squared plus 5. Okay, what we need to do is we need to write this in order of the exponents going from highest to lowest. Okay, so notice that this term, this negative 7x to the squared, negative 7x to the power of 2, has a 2 as their exponent, which is higher than this one, which has a 1 as the exponent. So let's write this term first. Negative 7x squared comes first. Okay, and then we'll write this because it has an exponent of 1, and this one has an exponent of 0, right? There's no exponents on this, right? It would be x to the 0, and we don't write that because x to the 0 is just 1. Okay, so let's try this one, 15x to the 1, okay, but we don't necessarily have to write that one there. And then lastly, we would write this 5. Okay. Anything that has 3 terms in it, which is what this is, 1, 2, 3 terms in it, we call this a trinomial. Okay, when it was one term, like we looked at before, that was a monomial, and sometimes we will have 2 terms, which we'll look at next. All right, so let's say that we had 7q plus 6q to the third. Okay, looking at the q's, which exponent is higher? This one has an exponent of 1. This one has an exponent of 3. So looking at the q's, which exponent is higher? This one. So we'll write that term first. So 6q to the third plus 7q to the 1. Okay. So looking at degrees in anything that's larger than a monomial, so it's something that has 2 terms or 3 terms, you only need to look at the first term, right? The term that we write in front, the one with the highest exponent. Okay, so the highest exponent in this is 3. So our degree in this is 3. Okay, let's take a look at a similar question. Okay, going back to our concepts of trinomials, let's say that we had 17 minus 4y to the 6th plus 7y to the 3. Okay, so again, looking at the variables, the letters in our equation, we see that there's a y here and a y here. Now we need to write this is again in order of exponent going from highest to lowest. So we see that the highest exponent attached to a variable is this one. So we would write negative 4y to the 6th first. And then we would write this one because the next highest exponent is 7y. The 3, the exponent of 3 is the next highest. And then plus 17 at the end. Okay, so now we've written this in standard form. We need to talk about the degree. Okay, again, whenever you have more than one term, the degree, you need to look at the first term that you have, and it's the exponent on that term. Okay, so the degree in this is 6. Right, and again, we call this a trinomial because there's 3 terms. All right, let's go and take a look at something else. Let's go and take a look at adding and subtracting polynomials. Right, so to add polynomials, what we need to do, what this would look like is something like 4x to the third plus 3x squared plus 5. Okay, and we're going to add this to 6x to the third plus 2x squared plus 7, right? So what do we see? We see one polynomial here and another polynomial here. Okay, so what we need to see is what of them have the same exponent attached to their variables. So the exponent on this one is a 3. In this polynomial, do we see another one with 3? Yes, right? So we need to do 4 plus 6, which is 10. And we get 10x to the third, right? So we keep the variables, the x to the third the way it is, okay? Same way as if you were doing 6x plus 2x, right? We know that 6 plus 2 is 8x, okay? So the next term that we see is this 3x squared. In this polynomial, do we see an x squared term? Yes, right? So we have to do 3 plus 2, which is 5, and keep the x squared on, okay? So the term, the ending, just is attached to it as if it was 2 plus 1x, right? So 2x plus 1x is 3x. So keeping that last part of it the way it is in your answer. And then lastly, the constant part. So 5 and 7, right? We see those are just numbers by themselves. So we have to add them, and we get this as our final answer. All right, let's take a look at something similar, but we will look at when we might be missing an x squared term in the other polynomial. Okay, so for example, if we had 3x squared, 3x to the third plus 2x squared plus 5, and then we have to add this to 6x to the third plus 6. Okay, so this is a 3 right here. All right, so first we see this x to the third term with a 3 coefficient. We see an x to the third term in this one also with a 6 coefficient, so that means we have to add the 3 and the 6 to get 9. And then we keep the x to the third term attached to it. Okay, in this one we see a 2x squared term, x squared term, but in this one we don't see any x squared term. So we'll just write that in there. Okay, it's basically saying 2x squared plus 0, right? 0, there's nothing there, so 2x squared plus 0 is just 2x squared. And then lastly, we see this 5 and this 6. So 5 plus 6 is 11. Now let's take a look at subtracting. Okay, what does it look like when we subtract? Okay, so for example, let's say that we had something like 4n squared plus 5 minus negative 2n squared. And I will just make this a 3 instead. Plus 5n minus 6. Okay. So the only difference between adding and subtracting polynomials is that when you have this minus sign, you have to distribute that minus sign to everything inside of the parentheses of the second polynomial. Okay, so that effectively changes the sign of everything in our second polynomial. So this becomes negative times negative is positive, 3n squared. Negative times positive is negative 5n, and negative times negative is positive 6. Okay, now we can just treat this question like we were before. Okay, we see a 4n squared, we see an n squared term in here. Is there an n squared term in here? We see one right there, so 4 plus 3 is 7n squared. Okay, we see a 5n term right here, but we don't see any n to the 1, right, term in here. So let's just add that in there. And then we see a constant term, right, 5. And there is a constant term in this one of 6. So 5 plus 6 is 11. Right. Let's go and take a look at the next question. Right. In the next question, we have a very similar question of just adding and subtracting. Okay, subtracting polynomials. So let's say that we had negative 2x plus 4 minus negative 3x minus 2. And just to make this a little bit different, I'm going to add a square sign right there. Okay. So again, whenever you see minus and you're doing subtracting polynomials, you want to make sure that you distribute that negative sign first, effectively just changing the sign of everything that's in the second polynomial. Okay. So this stays negative 2x squared plus 4. This becomes plus negative times negative is positive 3x, and then negative times negative is positive 2. Okay, so we see this negative 2x squared term. This x squared term, is there another x squared term in there? We don't see one, so we'll just write it by itself right there. We do see an x term, x being the next highest exponent, and we'll just write that in there. And we see this 4 term with a 2, right? They're both just numbers by themselves, no x attached to it, so 4 plus 2 is 6.